First lesson, 10th class. Lesson topic name is real numbers. Have you heard of this before? What is real numbers actually? See, there are numbers called natural numbers that starts with 1, 2, 3 and so on it goes. And the whole numbers 0, 1, 2, 3 and so on it goes. After the integers along with the whole numbers we have negative numbers as well and so on it goes. And after that the rational numbers which is of the form p by q but q not equal to 0. See, all this together called as real number. Actually, when we speak of natural number, whole number, integers and all, if we speak of 1 and 2 in the line number line means in between 1 and 2 nothing will be there. We started filling this natural number and after that the whole number will fill. So in between 1 and 2 nothing will be there. Once you started filling this rational number, all these gaps will be filled because those rational numbers are quotients. You come in decimal, all 1, 1, 1.1, 1.2, 1.3, like this, these gaps will be filled. How many numbers are there in between 1 and 2 can we guess? Infinitely many numbers are there. Okay? No, not n numbers. There are n means infinite. There are infinitely many numbers. Also, a number which cannot be written in this form called as irrational numbers. That also can be filled inside this. All together only we see those that is real numbers. Okay, so the real numbers includes only two type of numbers. One is the rational numbers, which are irrational numbers. Only these two type of numbers. In this rational number, we have integer, and we have whole number, and we have natural numbers. One is inside the other. Okay. So on the whole, everything together we call it as real number. In that, by the basic operations of real numbers, we may come across a definition called multiples and factors. Multiples and factors. What do you call a multiple? Taking the counting number and multiplying with the number what you are taking. For example, if I want multiples of 7, along with 7, all the counting numbers if we multiply against, that is called multiple of 7. It is called multiples. And there is another thing called factor. Given a number, by what number this given number will be divided completely? The divisors, right? The divisor, you can take any number. But when the divisor will become a factor, if the divisor does its job correctly, completely, without any remainder, then the divisor will become factor. So, right, the divisor is factor here. Why it is factor? It is dividing completely. See, the factors are 1 and 2. Likewise, you take the number 3. The factors are 1 and 4. Then that is 1, 2, and 4. Other factors are. What do you think the factor of 1? 21. 5 means 1 and 3. 6 means 1 is factor, 2 is factor, 3 is factor, 6 is factor. Okay. Now you see a number which is having exactly 2 factors. How many factors? Exactly 2, not only 2. Exactly 2 factors, no other factor other than are called prime numbers. What number? Prime numbers. Okay. And here 3 is prime or not? Exactly 2 factors. Of course it is prime. What about 4? Will it be prime or not? No. Then in that case, we say the number 4 is not prime, but a composite number. What number? Composite number means a number which is having more than 2 factors. Number which is having more than 2 factors. How many factors does this 4 have? More than 2. This composite. Then what we can say about this number 1? Exactly 2 means prime, more than 2 means composite. One is having only 1 factor. Are you thinking like, are you thinking like 1 has infinitely many factors? Like 2 can be divided by 1. Sorry, 2 will divide 1. 3 will divide 1. No, except 1. No, 1 will divide 1. So it is having only 1 factor. So we say 1 is neither prime nor composite. 1 is neither prime nor composite. So it is neither. And what did you say about 6? It is a composite number as it is having more than 1 factor. So we classified numbers based on the number of factors it has. Now, the prime number we have, right? In that we have 2 variants. One is twin prime, another one is co-prime. First we list out what are all the numbers are prime below 20. The prime number below 20. One is prime or not? No, it is not. 2 is prime, 3 is prime, 5 is prime, 7 is prime, 9 is prime. No, 9 is not prime. Then 11 is prime, 13 is prime, 15 is prime, 17. Again 11 points. So 17 and 19. Okay, here. So these are the prime numbers below 20. In this, when you observe closely, only these 2 is even among the prime numbers. So 2 is only even prime number. Apart from 2, all the numbers are odd. Okay. Now we were talking about this twin primes. So twin prime means the difference of the number. The difference of 2 prime numbers is 2. Take any 2 prime number, 2 and 3. What is the difference? 1. It is not 2 prime. Take 3 and 5. 2. So 3 and 5 are twin prime. 5 and 7. 7 and 11. No. 11 and 13. 13 and something. Just like we may find these are different. Now what we going to say next is very important. Co-prime numbers. What numbers? Okay. Co-prime numbers means given a two number that has common factor 1, the numbers which are having common factor as 1. For instance, take 3 and 4. List out the factors of 3. 1 and 3 are factors. What are the factors of 4? 1, 2. Among which is common? Common factor. Let me write this one. See, 3 is number, 1 and 3 are factor. 4 is number, 1, 2, 4 is factor. Which is common among the factors? 1 is common. Apart from that, common is 1 is common. Then, apart from 1, there is no other common factor. Okay. So, as per the definition of co-prime, the number 3 and 4 are co-prime. Okay. What you can say about 8 and 9? That is co-prime because only one can divide both the numbers. Other than one, no number can divide this. Right? What about 9 and 12? Are they co-prime? 3 will divide. Okay, 3 and 1. So this is not a problem. Clear? This is very important. Okay. And after this, one more thing. See, here 3 and 4. In this 3 is prime, 4 is not prime. Here 8 and 9. Is this prime or not? 8 is not prime, 9 is not prime. But 8 and 9 is co-prime. So, the number involved in co-prime need not to be prime. Number which is involved in co-prime need not to be prime. Also, the consecutive numbers are always co-prime. Number which comes one after another, those are always co-prime. Okay. Now, in this note, we have the fundamental theorem of arithmetic. What does the fundamental theorem of arithmetic say? See, we know about factors, right? Factors means what? Exactly dividing the given number. Okay. Take one opposite number for example. 10 is an opposite number. You try to express this as a factors, product of factors, which involves only prime number. What is the least prime number that is available? 5. Yes. Prime number, least prime number. Okay. So we can write 5 2s are. Okay. So here 2 is a factor. Also that 2 is prime. 5 is a factor, also that 5 is prime. So that is why we have prime factor. What factor? If the factor is prime number, then that is called as prime factor. composite number. I'm taking 105. How this can be prime factored? What is the least prime number that can divide this? 2 will divide this number or what? 3 will divide this number. So when you divide it by 3, what answer you are getting? 35. Okay. Then this is prime. Whenever we write this side will keep it for prime. Then here, this will be written as, what is the least prime number that will divide this? 5. So 5 into 7. So this 105 can be written as, complete this 3 into 7 into 5. Okay. But actually it should be written in the ascending order, small number to be 3 into 5 into 7. Likewise, this number 10 can be written as 5 into 2. Now, is there any other way this can be written as a product of these numbers except the order of the number? Like you may write any number from there, but I am talking about the ascending order. Any other way of representing this number as a product of primes? Is there? No. There is no other way. Only in this way. That is what this fundamental theorem of arithmetic states. Given any composite number can be expressed as product of prime factors. Can be expressed as product of prime factors. As per the statement, it states that every composite number can be expressed, which means factorized, as a product of primes, and this factorization is unique. This factorization is unique apart from the order in which prime factor occurs. See, every composite number every composite number can be expressed as product of, expressed means factor, product of primes, and the prime factors are unique except the order of the number. We told you, right? Except this 3, 5, 7, 7 by 3, that order may be different, but what are all the prime factors included will not change. Okay? And we have done one thing here, right? This somehow looks like a tree, the branch of the tree. It is called as factor tree. One tree. Factor tree. This tree, in which all the branches of the tree is factors. Whenever you do this factor tree, you should allocate the right side for prime numbers. Have you noticed that? 3, 5, 7, like this. Also, 1 should never be part of this factor. The number 1 should never be part of this factor. Why? Because we are speaking of prime factors here. What is prime? Now think of the statement. The prime factorization of 5. The prime factorization of the number 5 is 1 into 5. Is that true or false? Yes. 1 is not prime. So, what is it is prime factorization. So, this like we should not mention. Okay? It's wrong. Prime factorization 1 should never come. Only prime number should come. And prime number also in ascending order we should write. Okay? So, as we have seen, this expression is unique. Unique means no other way, no other prime factor we can do this. Okay. Now, what you can say about this 4 power n, number which is 4 power n, this can end with 0 or 1. Whatever the number given, we will try factoring it. How this 4 can be factored? 2 into 2 whole power n. That makes 2 square whole power n means what? 2 power 2n. Now check all the 2 power n. The n takes the value 1. N is very natural number, right? Any value n. N is a natural number, starts with 1. So 2 square we have 4. If n is 2 means 2 power 4, 16. If n is 3 means 2 power 6, it is. Are you seeing any 0 here? If n is 4 means 2 power 8, 256. And 2 power 10, 1024. Only 4 and 6 is repeating. And how you will write this proof? For that, this fundamental theorem of arithmetic typically becomes. See, for any number to end with 0, two and 5 both should be factors of the number. Okay. Also, this prime factorization the factorization of this 4 power n is unique. Why? By the uniqueness of this fundamental theorem of arithmetic. As you know, cannot be anything other represented in another. Okay. So as this is unique, there is no way that 5 can be factored. 5 is not a factor. So therefore, this 4 power n will never get to 6. This 4 power n will never get to 6. Now, in the same way, think of 6 power n. 6 power n, you just repeat the procedure. You just repeat. 6 can be factored as what? 2 into 3 or 3 into 2. You know, ascending order. So, this you can write it as 2 power n into 3 power n. And the same story, that is for any number beginning with 0, 5, 2 and 5 must be a factor. Here 2 is the factor, but 5 is not a factor. Why 5 cannot be a factor? Because by the uniqueness of fundamental theorem of arithmetic, an expression is unique, it cannot have 5 as well. So therefore, this 6 power n cannot get with the 0. Okay. These are quite important type of questions. Only 2 questions are in this textbook. Likewise, many questions will be asked. Sometimes 5 power n. Likewise, they may ask, but the story is still, you should write the prime factor. Five power n, 5 will come. 2 should be a factor, right? Then only it will come like 0. Okay. So the same story you have to write, but instead of 5 cannot be a factor, in 5 power n we should write 2 cannot be a factor. 10 power n is there, then surely it's 0, man. You don't need to prove that it is already there. Yeah. Very easy type of question. Also, one more question or example for exercise. Explain why 7 into 11 into 13 plus 13 is composite number. 7 into 11 into 13 plus 13 is composite number. Why this is composite number? See, we try to express this as prime factors, but it is having plus here. So I will take the 13 out. Then we may have 7 into 11 plus 1. This itself enough. As you can see, 13 is a factor. The factors of the number like this. Factors of the given number. See? Wait, we can multiply and add, but all okay. What will write? The factors of the given number, we see what happens. See, 13 is a factor because product. Also, this 7 into 11 plus 1 is a factor. Also, 1 as a factor. Totally how many factors? One factor, this is one factor, that is one factor. Okay, this is fully one factor, this is fully one factor, this is fully one factor. Then, 3 factors. When a number have more than 2 factors, then it is composite number. That is all. Okay. Or else, you can write 7 11s are 77, 77, 77 plus 1 78, and the prime factor of 78, that expression, which will have more than 1 factor, therefore the number is composite like this. Okay. And the other question, 7 into 6 into 5 into 4 into 3 into 4 into 1. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Why it is composite number? See, in this 5 can be taken out. Then the remaining 7 into 6 into 4 into 3 into 2 plus 1. Likewise, 5 is one factor. The all number which are in the bracket, that is a factor. also a factor. Totally how many factors? 3 factors. So as it is having more than 1 factor and more than 3 factors, as it is having more than 2 factors, this is composite. That is all. That's this. So that is it with this first section. What are the things we discussed? Starting from the type of numbers. This one. Where this one is coming, you are asking. One is a factor of all the numbers. All the numbers can be divisible by. All the numbers can be divisible by 1. Is it or not? You take 780. This can be divisible by 1. And the quotient is again 780. Without remainder. That is why 1 is factor of all the numbers. Okay. Okay. See, that was it. What all the things we discussed so far? The types of numbers. On that, what is multiples, what is factors. Based on number of factors, how we classify the numbers. Prime and composite. 2 factors means prime. More than 2 factors means composite. One is having only 1 factor. Prime, not composite. Also, among prime also, we just divided that into 2 different groups. So we have found out 2 different variations of the number. One is pin prime, another one is co-prime. Pin prime has reference to 2 given prime numbers as reference to that is pin prime. If the dash common factor as 1 means, then it is called as co-prime. Also, there is a note that the numbers which are involved in saying co-prime need not to be. Whereas, to say twin prime, the involved numbers must be prime. Okay? Are you confused? Okay. Then shall we move forward to the next section? LCM and LCM.